So yesterday we did look at different variables, and we not variables but data types. So yesterday we looked at the different data types and the basic features of Solidity, which has similarities with Java, JavaScript, and Python, and mostly in terms of the Boolean, conditional, and arithmetic expression. We also take a look at logic, and logic operators, and arithmetic expressions. We also looked at arrays and loops. Yeah, we also did take a look at. I hope you can see my screen. So we also did, yeah. So we also did something with data types that are available in Solidity, and that was the unassigned integer, unassigned and assigned integer. We also talked about many. So we also talked about Boolean that returns a true or false, and also the logic operators, that is not, and, all, equals, or not equals to, not equal to. Then we talked about integers and uint, and they normally have an incremental values of 8 bits to 256. Then we talked about fixed and unfixed, also has an increment of 8 bits all the way to 256, and n is the number of decimal places. Like it can start from unfixed 32 bits multiplied by the number of decimal places, that is 2. And then we have address. So these ones are reserved words or keywords that are normally used in Solidity. They are used in the compiler. And then we have enums, and then we have structs, and then we have arrays, and then we have mapping of address, or it's a hash table. It's like a hash table for lookup, hash lookup with key and value pairs, mapping the key type, the key that you are looking, normally from the struct, and the value of that particular key. Then we have time units, which normally has minutes, seconds, hours, and days. So when you are creating a contract that will be looking at time, you need to use the time unit, whether in minutes, seconds, hours, especially if you are creating a decentralized exchange, or you are creating an exchange, you need to use time to calculate, to keep the time of when the order was created and when it was filled. Yeah. So then we did to take a look at libraries, and how you actually do an import. So we talked about libraries and how you do imports on Solidity, and the functions or the work of a library is to actually create different functions that can be imported or used in another contract or in multiple contracts. So we talked about so those were the things that we did take a look at yesterday. So there is something that I wanted to share with you and give more about smart contracts. So we have smart contracts as as assets are no longer passive object but have dynamic behavior. So with smart contracts, objects have a dynamic behavior, and behavior can be fine-grained associated with each transaction. So these objects are normally like the students can be an object, and they can be associated with with a transaction. So you can associate a student with a transaction and store that data as a transaction and hash that data. So contracts can be digital entities. We have also learned that that can send and receive value. So most of the time, or most of the times when you will be interacting with smart contract, is that most smart contract will be sending value and receiving value. So when you interact with an NFT, you are actually sending and receiving value in return. So you are sending if that is, you are sending value, and then you are receiving value on your end. That is the NFT. So we have contract can spawn of other digital entities and create an autonomous ecosystem. So once you have like created a big like once you have created your smart contract, this smart contract uh, can actually communicate with other entities and create an entire ecosystem, an autonomous ecosystem. Let me show you a diagram of what I mean by creating an ecosystem. Not that one, that one, this one, yeah. So these are blockchain for like a smart city. For a smart city. So we have the safe city, we have smart living, and we have smart people as the application layer, and we have smart mobility and smart government and smart environment. So this is the application layer of the of the of our smart contract. And then we have the infrastructure, that is smart city enabling platforms. So this one, as you can see, we have the blockchain here, and then we have the smart contract here as the application layer, where these layers are communicating with the smart contract to actually perform this, to communicate with the infrastructures. And we have the smart city infrastructures, we have the data centers, we have active infrastructures. So for data centers, we there is a guy who is doing something blockchain or data as a public service. Data as a public service, and he's trying to use blockchain so that people can be able to access data and information. Then we have systems, we have passive infrastructures, and we have active infrastructures. Uh, these are like the hospitals, the the banks, now trying to incorporate blockchain for people, for smart people, for smart people, and for smart government, like those of developed countries like Dubai. And then we have the blockchain in internet and P2P network and data center, power computing, and storage and content. These are the infrastructures for blockchain. So we have internet, that is 5G and 4G and such infrastructures. So when you can actually create an autonomous ecosystem, whereby you don't need to be there physically for a transaction to happen. You don't need to be there physically, so that you can be able to trust the process. So on my WhatsApp status, I had asked if somebody knew who was Satoshi, what would you do? Like, would you still trust the system? Would you still trust the system? And one of my friendly tried and said that he would actually like remove or withdraw all his bitcoins, and uh, then yeah. So with blockchain, you don't need like to create trust. You don't need to be there physically so that people can be able to trust you. So that is the advantages of autonomous systems, and it also saves you time because if you're not there, if you're not physically there, it means that you can be able to attend to other works and other businesses, so making life easier. And yeah, the motive for technology is actually to make life easier.
But Satoshi is not a criminal.
Yeah,
So why
so,
would the guy trust him? He's not a criminal. This Bitcoin is not a Ponzi scheme.
yeah.
I mean, it's something that you see. They have a project they tie it to, just like Ethereum. So I don't think one should be afraid. I
Yeah,
don't know.
yeah. But the core or the core reason why Bitcoin actually has that big value is because there is nobody who can be able to blame. Like, if your money get lost, you can't go blame the bank. If there is something that fails, there is we are just trusting the algorithm. We are putting our trust on the algorithm because nobody is in control of anything. It's
Yeah.
like free will for money.
Mm.
Free will for money. Nobody money has free will.
Mm.
Nobody like controls your money or your thoughts. Yeah.
It's a, it's
So
a,
yeah,
it's a, it's a blind trust.
yeah. So it has a strong caveat on smart contracts have strong caveat, meaning that technology is not ready because it relies on conventional software programming languages. And we have future smart contract platform will be mathematically verifiable. So we have actually seen this some of these contracts which are mathematically verifiable through the proof of stake and proof of work and those kind of consensus mechanism. And then we have that some of this line will be no more than 200 lines of code at this point. Yeah. So some of code actually they are not big codes. I've never seen a smart contract that is has a lot of lines of code. Maybe the one for Uniswap, or like this one. You can see this one is like 69 lines. That's 69 lines.
Well, maybe by the time the Nigerian digital currency come out, you might see over 200 line of code.
Yeah, most,
You know,
yeah.
because they have to consider a lot of factors. Definitely, for the Nigerian digital currency, you might see more than 200 lines of code.
So yeah, they are usually not that much because if you remove these comments like these ones and this another comment. So if you remove these comments, you will be left with less than 200 or maybe 200 if you remove the comments. Yeah, so they are usually not long, unlike these other softwares whereby you write like a thousand lines of code, and you let alone you have to like update the system. Then we have two types of smart contracts. So one we is the deterministic smart contracts, and then we have non-deterministic smart contracts. So deterministic smart contract are smart contract codes that do not depend on outside information other than the information on the blockchain in which they live into be triggered and work efficiently. In other words, the blockchain network facilitates the smart contract with sufficient information to make decision. So most likely like peer-to-peer lottery. An example is a peer-to-peer lottery. The funds are held on the blockchain network, and random numbers are also generated by the smart contract code. At the end of the lottery, the funds are transferred by the winner to the winner's account via his or her address on the blockchain. So they don't require like outside information, and that's why they are called deterministic smart contracts. The information is already inbuilt on them, and they actually they rely on the blockchain itself. So these are the deterministic smart contracts, and then we have non-deterministic smart contracts. So some of these non-deterministic smart contracts, in non-deterministic smart contract, the network facilitating the smart contract code does not have sufficient information to make decision. Thus, an outside party is needed, usually called an oracle in the computer science domain. So an outside party is needed, and decision about value flow based on human behavior, events like price drop or hike, or even prediction. However, research has shown that using external state does not always introduce the need for trusting an additional party. So, for example, in a driving license renewal scenario, the government is a trusted party, and thus we use government as a validation oracle that injects external state into the blockchain. So you remember external state, or external state is external data, data that is from the outside, or personal information that will be validated by the government when you are renewing your license into the blockchain. So Oracle connectors are known in computer science for their ability to provide information from outside a system that the system itself cannot acquire. Oracles also store the data and only pass the important and relevant data to the smart contract. So this ensures the security and high privacy of the network and improves efficiency. Improves efficiency. So yeah, like for the example of driving license renewal, if we were to create a deterministic smart contract for this, we will be faced with a lot of challenges, because we will be building it based on assumptions that everybody who wants to renew their driving license is these years old, you know. But there are factors that you like need to consider when you are also creating the smart contract, whether your smart contract will need external data, that is data coming from users or from another source. Yeah, because for example, for like a hospital record or smart contract, for a smart contract based on the hospital records, you will also need information that is coming from the nurse or the doctors. Yeah, because some of these information, like the diagnosis or the treatment, will be from the doctor themselves. So yeah, so I felt like I needed to share this before we move on, because it's important to know that we have two types of smart contracts: the deterministic and oh god, non-deterministic smart contracts. Yeah. So these other ones are decentralized application and the flow of the DApp creation. So we have already, so we are still on the compiler. We are still here on the compiler, Solidity compiler. We haven't actually moved further ahead, but from what I was showing earlier, the H2O trust. This is the flow of the information, or the flow of DApp creation. So you create your smart contract using Solidity, and then once you have created your smart contract, you compile using the ABIs or the JSON files, or the contract ABIs that have been generated by the compiler. You now use them for front-end rendering, and yeah, so you can either use HTML, or you can either use uh, React Native for front-end rendering. Then for backend, you can use JavaScript or any other scripting language, that is PHP or Python or Ruby on Rails, and you can now send the transaction to an Ethereum node. Yeah. So once you have deployed the contract, you will deploy this one on the Ethereum client, that is the mainnet. Yeah. So that is just a simple workflow for Adapt. But for now, we are still here. We are still here. Yeah. Yeah. So today I wanted us to do something on transaction, on how to use the message dot sender, and so message dot sender. Let me show you. So you have actually seen, like, in our first um, not that one, our bank. I think it was in our bank, not our bank. Yeah. So just let's just go through this. So we have variables that are predefined. They are global variables, and they are always denoted with something like message.sender, message.value, or something like message.data. So just a minute. For these variables, they are normally denoted with a message. So the message of MSG, it's not MSG. It's not Uncle Rogers MSG. So they are object. The MSG object is the transaction call called by the externally owned account or message call, and that launched the contract execution. It contains a number of useful attributes. So this message object contain useful attributes. So these attributes are these attributes are like message dot sender. So we have message dot sender. So message dot sender uh, represents the address that initiated the contract. So let's the contract, the address, the address that that initiated the contract. So the address that deploys the contract is always written as message.sender. This is the one who has actually initiated the contract, and and initiated the contract call. So it not necessarily the originating EOA or externally owned account that sent the transaction. So if our contract was called directly by an external account uh, transaction, then this is the address that is signed the transaction, but it will be it, but otherwise it will be a contract address. So there are two ways. If you sign a contract, you can have the message. You can be just the message dot sender. You can be just the message dot sender. Then all you can be. Just keep in mind that message.sender is just the address of that has initiated a transaction or a contract or a transaction call in a contract. It can be it can be your address, it can be the owner of the account, it can be anybody, but it's the address of the external account that has initiated uh, EOA that has initiated the contract call. Then we have transaction call. Then we have what we call message dot value. Message dot value. So instead of lighting value, instead of like lighting value from our previous contract here, where we were saying amount value equals amount. So we can just say message. We can just say message dot value. So this message dot value. So this message dot value will be will be will be our value. It just represents the value of the person who have sent that value. So the value of if sent with this call, it can either be in way. So the represents the value reps. Uh, reps the value. Represents the value of is either sent either in sent in the in this call, the above call that was initiated by message.sender. So it can either be in it's always in way, it's always in way. So when you're writing your code, you need to like convert it to either. You have to convert it into either so that it's readable, because way is more like it's 18 decimals, so it's a long number like this, so you need to like convert it into ETH so that it becomes like maybe 1 ETH or something. Yeah. Then we have message.gas. So message.gas is the just minute. So message.gas gas is the amount of gas left in the gas supply of this execution environment. So this was deprecated. It was actually deprecated and was replaced by the gas left. So it was actually replaced with gas left. So yeah, it now uses gas left. It's the gas left, that the gas that has been like yenye, the leftovers. And then we have message.data, the data payload of this call into our contract. So message.data. So message.data, it's the data payload of this call. Yeah. So that is the global variable. And then we have the last one, which is the first 4 bytes of the data payload, which is the function selector. So this is a message. Yes.
The gas left is that's the same na what they call a I think it's UTXO,
Uh,
unspent transaction output.
yeah. Unspent. Yeah. So that is what they call that is the gas left. Yeah. So then we have the message dot sign, which is the first 4 bits. So it's the first 4 bytes. So you have bytes and bits, bytes of the data payload. So most of these things you will normally see them in a contract. In a contract, and also you will normally see them in transactions. So let's just see if we can be able to like get one transaction. And yeah. So if you click here for more, we have gas used by the transaction, and then we have the input data. So this that data that we are talking about, message.data. And then we have the normal token transferred. So we have this token was transferred to this particular address, to this Uniswap version 2, and then to this particular, and then this was the rapid that was generated. So then we have internal transactions, and then we have the log. So here from the log, we can be able to now see this data in details, or the logs of this particular transaction. And then we have the topic, we have the data value, and these are some of the events that have been also been emitted. So events Because today I wanted us to talk about events. Uh, yeah, events. Events, events. Yeah. So here we have the events. So when a transaction completes, it produces a transaction receipt, and the transaction receipt contains logs, entries that provide information about the action that occurred during the execution of the transactions. So event in Solidities are the Solidity high-level object that are used to construct these logs. So event are especially useful for the light client and app services, which can watch for specific events and report them to the user interface or make a change in the state of the application to reflect an event in an underlying contract. So these are the logs. These are the logs that I'm talking about, and we have the name or the event that was emitted. So this is this is a transfer event that was emitted when the transaction was conducted by this particular address to this contract. So events are very useful because they help you record and see what has been called in the contract. So they help in when it comes to auditing and audit trails, and yeah. So as you can see, this address has been has done a transfer and withdrawal, and if you just view the source code, it will take you to the source code of our contract that is on Etherscan. Yeah, so events are very important because you want to like know what actually went through. So we have this contract that we'll be using to emit events, and also we have a modifier. This is owner. So modifiers, with modifiers, give you a definition of modifiers. So modifiers actually can be able to like modify the state of a specific function. They can actually be able to, yeah. So function modifiers in Solidity. Solidity offers a special type of function called a function modifier. You cannot apply modifier to function by adding the modifier name, as we have done here, and then the modifier name in the function declaration. So modifier are most often used to create conditions that apply to many functions within a contract. We have an access control statement already in our function. So this one. So they create conditions. Modifiers create conditions that only a specific person can, or only a specific thing that needs to happen so that this function can be modified. And for our code, we have a modifier called is owner. So this is owner. We have created a condition whereby that only the message.sender, the owner of this particular contract, is supposed to be payable. The function should be payable to him, to the address. So we have the value, and we have this another modifier that specify whether the value is valid. It has a condition to message.value, and it says that our transaction, the transaction of the the action that we'll be doing, we are supposed to have a value that is greater or equals to an ETH. So if we don't have one ETH and we try to do a transaction that is use 0 point something or 0.00, then the transaction will not go through. Then we have the constructor. So this constructor is outputting the owner of the contract uh, as message.sender, And then we have this function, public payable. So this function is payable. It's a payable function. It means that it can receive ETH. And then we have the modifier now, the modifier function stating that only owner should be able to accept this value. Only owner should be accepting this value. And then we have another condition that we have. This modifier function that we had here, it's been used here, or we have called it here at the end. So apart from, if the first condition is meant, then the second one should be checked. So the second one is to check whether the value is of whether the value is greater than 1 ETH. And then we emit these events. We emit these events up here. So the first event should be log the sender address. It should log the sender address. It should show the sender's address. And then the other event should show, or should log the value of or the unit, the uint, the value that we are sending. So this one is quite simple. So we will deploy and see if it will actually do as what we have specified it to do. So transaction. So just like our norm, we can either inject web. We can either inject web oh, sorry. Let's just use the JavaScript, because I'm running another application. So right now I'm using the local build, that is Ganache. So let me just change the network. Then we inject. Let me save. So as we wait for it to load, so you have introduced two things, three things actually. One is one is the predefined global variables that are available on Solidity. And then we have talked about events and modifiers, or function modifiers. And so this is a transaction, our contract, and now I think we can inject. Yeah, we can, and want us to deploy it there and try and see if we can be able to. So here we will add our value here. We will add our value there. and we will start with a 0. We'll start with 0 and do a transaction and see. So let's see. And yeah, so let's see if it has emitted some event. So our value was 0, and we were trying to send to the owner. So you see, so from this address to this address. So we were sending to the owner of this address, that like we have specified. So like we have specified. So another thing that we want to look is the events. Should have yeah. So this is the event. Yeah, here we have a reference of the sender event. So this is our event. No, should it should be here. So the transaction actually has gone, and we have seen that it went through. So we can the event should be here. I'm not sure. Some of the event should be here. The event should be here. The event should be here. Yeah. But if you are on limits, if you deploy this contract on test net or in a live net, they usually appear here. Yeah. So the next test that we should do is we change this particular address, and we change this particular address and use another address which is not the owner's address. So like we deployed our contract at this address. So if we try to do the same here and transact, it should emit diffuse, or it shouldn't go through. It should revert. Okay, it has actually gone, but I don't know. Not sure. Let's just use the other one. Let's deploy using this other one, and deploy. Then let's try. Yeah. So there is a fallback because this is not the address of the this is not the owner of the address. Yeah, this is what I was looking for. So this is not the owner of the address. So our contract is working all right, and it wasn't mined because so it should always fall back. It should always revert because this is not the owner of the contract. So if we deploy it again, I'm not sure whose address is this one. So let's deploy it at that particular address. This is 5. Yeah, so we have deployed it at this particular address. So this is the owner of the contract now. So if we try to do it again, it should transact, and it should actually be successful. It should be successful. So yeah, here we have the contract was successful. The contract was successful. But if we try to transact with a 0, try with a 0. Well, therefore, for the 0, it's still not working as intended. Let's see. Yeah. So I'm not sure why the 0 is working. It should revert. It should revert. It should revert. It shouldn't go. Because this other one was okay because we were sending. This one was invalid. It's actually didn't go because we were sending to the. We were not the owner of the contract, but basically we have seen how we can add this part. I think this one is not working. So this modifier is not working. This one is not working. This modifier is not working. But the other one for owner is working. The modifier for owner is working. Yeah. So the modifier for the owner is working. Yeah. So you can try that and experiment on different on adding more modifiers. On adding more modifier. Yeah. So and then something that yeah, so that's it on modifiers and event. Modifiers and event. Let me check whether there's supposed to be a plugin. Hello? Hello?
Yeah, we can hear you. I'm with you.
Yeah. So yeah, that's it on events and modifiers. So tomorrow we will look at uh, mappings. We will look at mappings, how to map data, Yeah. So only allowed for state variables, and mappings can be seen as hash tables, which are virtually initialized, such as every possible key exists and is mapped to a value. Yeah, so we will try and we will do a mapping of balances for the message.sender. So we will use this simple contract available there. And then we have actually talked about global variables. This is the message.sender. Then we talked about message.value, and then we have now. So most of the time now is used when you want to use the current time. Like now, uh, this is how you initialize it. So you can define a variable here. You int time, and then equals now, like that. So it should be time, something like that. So you can yeah, so you can kind of define it like that, and then it's not capable of something like that. So you can define it like that, like a string can handle it. Yeah. So now is normally used like that. It's universal for every language, even in JavaScript and in Python. They normally used now, yes, to show time. Then we have talked about this one. We have actually talked about visibility for functions and state variables. So we have talked about public, private, internal, and external, and external functions. So public can be called either internally or from messages. Default for functions can only be called from the contract that it is defined in, and not from derived contracts. So it cannot be called from outside. And internal can be called from the contract. It is defined in or in derived contracts. Default for state variables. So external can only be called from other contracts via transactions, cannot be called internally. So most of these external functions are used in libraries, and interfaces. So like this one, we have function. Then we don't have an external. And there, yeah, in bank we had an external. Yeah. So they are normally used in interfaces and libraries, so that they can be called in other contracts, but they cannot be called inside the interfaces. So they are best, the external function are best used in interfaces where you don't need to like use that function in that yeah. So that's it for today. In case you have a question or a comment, yeah, is the time.
Yeah, sorry. The slide for yesterday, we ask, just to go through some of these things so that while we are trying to enter the code, we can see some, to serve as a guide.
Yeah, today I did upload the list of the slides. Let me see. It's on Drive, the same PDF, not the same PDF, but the same folder, ADS. So in this ADS folder, I added an extra, some extra. I have there. There is also an extra folder. There is an extra folder here.
Okay, I've not checked that. I will check.
Yeah. So I have added most of the PowerPoints and most of the lessons that we have learned, and then I have an extra folder here with extra slides. Extra slides. Yeah. So okay. So yeah. So I will add the one we are doing right now. This one. I will add this one. Yeah, this one is the only one which is missing. So this one is the only one which is missing. Yeah. So we have also done inheritance of smart contracts using the is to inherit. Yeah. So we have actually done quite a lot, and yeah. So you can see you can actually use the is to like use in multiple by so that you can like use multiple contracts. So this is the first one using the is motto, and then this is the final one now consuming, and that's how cryptocurrencies are built. So we have the ERC interface, we have the safe math, we have the ownable, we have the entrancy guard, we have another function, another one for proof of stake. Then they are inherited, and then they kind of make the ERC20 or the NFT, the non-fungible token. Yeah. So I'll share this one, and I'll also share the code. So the only thing that I've not shared is the code and the this slide. Yeah. So yeah, so that's it. Yeah,
Yeah, that's fine. Thank
yeah. Uh, mhm. Yeah. So I've been able to get somebody who will be able to like talk on most likely next week. Next week. I'll also talk with someone else so that we can we can have we can invite him on one of the sections. So I'll confirm with him if he will be available next week during this hour, so that he can actually talk and tell us what it's like to work in a blockchain. Yeah. So yeah, yeah,
you. It's okay.
yeah.
Yeah. Yeah, thanks.
Yeah. So any question from you, Damaris? Any?
No.
Okay. So how far is the on how far are we now into the deep?
Well, we are still at the shallow end. Yeah. Not we are getting deeper, but not too deep.
Okay. And you, Damaris, how deep are we in the deep?
Mm, I think we are a bit. For me, I think I'm almost. Sometimes I'm almost drowning, but I find my way.
Okay. Okay. Yeah. So I tried to like make the class a bit simple with simple smart contract, and yeah, even though yeah. So I'll make sure that by the end of the course you will be uh, not drowning. So bye and enjoy the rest of your evening.
All right. Thank you very much.
You too.
Yeah.
Okay, bye.
Yeah. Bye.